Okay, in today's video, we're going to look at two relationships. We're going to look at the relationship between multiplication and addition, and then we're also going to look at the relationship between division and subtraction. So we're going to combine both of those into one video today. Now, let's start off here by looking at these two expressions. My first expression is 2 plus 2 plus 2 plus 2, and my second expression is 4 times 2. Now, what I'm going to do is I'm going to do a tape diagram for each of these. So let's start with 2 plus 2 plus 2 plus 2. So I'm going to start with two boxes, 1, 2. Then I'm going to add two more, 1, 2. Then I'm going to add two more, 1, 2. And then I'm going to add two more, 1, 2. Okay? Now let's do a tape diagram for 4 times 2. So I'm going to start off with 4, 1, 2, 3, 4. And since I'm multiplying it by 2, I need two sets of that 4. So 1, 2, 3, 4. Now, if I take a look at both of these, again, 2 plus 2 plus 2 plus 2. I have a group of 2 here. 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 So 2 plus 2 plus 2 plus 2. For my 4 times 2, I had my group of 4. So 4, I had a group of 4 there. Okay, what am I noticing about these? Well, if I'm thinking about these really hard, I should know that the 2 plus 2 plus 2 plus 2 equals 8, and the 4 times 2, which is really just 4 plus 4, equals 8. So I'm saying that these two things are giving me the same answer, or they evaluate the same way. So what I can say is, I can say that these expressions are equivalent. And equivalent, we know, means equal. And we know that since they have the same value. Okay? Again, we know that both of these expressions are equivalent because they come up with the same value. So let's take a look at this expression, 3g. Now, there's a few things we have to take note of here. First of all, I can see that I have this g right here. Okay, the g is our variable. Okay, a variable is just a letter that's representing a number here. So we don't know what g actually represents, but we do know that it represents some number. Okay, I can also see that I have no operation between the number 3 and the variable g. Anytime we don't have an operation shown to us, that's telling us really that that means multiplication. So sometimes you're not going to see an operation between a number and a variable or between two variables. That just really means that there's multiplication going on in between those. So I'm just going to put a little multiplication dot in there so we don't get confused. Now, what I want to do here is I want to make a tape diagram to represent this. 3 times g. So if I'm thinking, okay, if I have 1 unit here, I can say that this 1 unit right here is a g. Okay, that's my g. If it's 3 times g, that's telling me I'm going to have 3 of these g's. So 1, 2, 3. And again, this would be a g, this would be a g, that would be a g. If we think back to what we just saw on the last little slide, really this would be g plus g plus g. So what we can end up saying here, based on this, if we have the expression 3g or 3 times g, that's the same thing as having g plus g plus g. So now if I'm thinking, well, if I have a different example, say I have, let's say, m. If I have m plus m plus m plus m plus m, well, what's that equal to? I know that because there's a relationship between multiplication and division, I have 1, 2, 3, 4, 5 m's. I could be saying that's the same thing as 5 times m. Okay, and again, if I needed a tape diagram to help me out, I would have 1, 2, 3, 4, 5. Or I have one of our m boxes 5 times. Okay, those two things are equal. M plus m plus m plus m plus m is equal to 5m. Okay, let's take a look now at some relationships between division and subtraction. So I'm going to start off here with 10 units. Okay, 10 units. So I can see that I have 10 boxes there for my tape diagram. Now what I want to do is I'm going to divide each of these into 5 sections. So let's say divide into 5 groups. Okay, so I'm going to take those 10 boxes and divide it into 5 groups. So I would have my 10. And if I need to divide it into 5 equal groups, I can see, boom, there's my 5 equals group. Here's a group, here's a group, here's a group, here's a group, here's a group. So let's think, how many squares are in each of these 5 sections? Well, there's 2 squares in each of the 5 sections. Here's 2, here's 2, here's 2, here's 2, here's 2. So if I wanted to write a number sentence to demonstrate what happened, I'm going to say I started with 10, I divided it by 5, and then I equaled 2 in each group. Okay, so there's my number sentence. Now let's start back over here with 10 more units. Okay, we just saw division. Let's see again with 10 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this time I'm going to start subtracting. Okay, so I want to start subtracting here. And what I'm going to do is I'm going to subtract. So I'm going to subtract by 5. So I'm going to write that out. Subtract 5. So now if I take my 10, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I subtract 5, I'm losing boom, 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 boom. So if I started with 10, I subtracted 5, I can see that I have 5 left. Well, what if I subtract 5 more? So 1, 2, 3, 4, 5. And if I subtract 5 more, 1, 2, 3, 4, 5, we can see what I'm left with here. I'm left with none. So I had 10 minus 5. I subtracted another 5, and that equaled 0. So now looking at my 2 expressions I ended up with here, my 2 number sentences. I had 10 divided by 5 equals 2, and 10 minus 5 equals 0. Do I notice any relationship between them? Okay, let's think. Do we see any relationship between these two? Well, hopefully we're starting to see one a little bit. I can see that if I subtract our divisor from the dividend, there's going to be no remaining squares, meaning if I subtract my divisor here from my dividend this many times, we're going to end up getting nothing left. So if I take my 5 and subtract it from 10 2 times, like I did down here, I get nothing left. So what really does that mean, or what does really that give us? Well, that helps us if we have an equation or a number sentence with a variable that we don't know. So say I have 12 divided by x, and that equals 4. What this is telling me is, because I know that there's a relationship between my division and subtraction, I know that if I start with my 12 and I subtract from it x 4 times, so minus x, minus x, minus x, minus x, it should equal 0. Now another way I could think of this, again, my expression 12 divided by x equals 4, is I could think of it as 12 minus 4 minus 4 minus 4 equals 0. Because I know eventually I have to get down to 0, so if I do 12 minus 4, that's going to be 8. That 8 minus 4 is 4, 4 minus 4 is 0. And now I can be thinking to myself, maybe this will help us out. Now I can be thinking to myself, how many 4s did I actually subtract here? Well, I did 1, 1, 1, 1, 1, 1, which gives us a total of 3. So my x is going to end up equaling 3 here. And if I go back and check, 12 divided by 3 does equal 4. That works out. There's my x.